Hi, in this video we are doing a quick review for finding the volume of a solid about the axis of revolutions, and we reviewed the disk, the washer, and the cell methods, and which one should we use for a particular problem. So just a quick review. When using the disk methods, so we have the formula pi, the integral from the lower to the upper limit, the outer radius square minus the inner radius square, and then either depending on the x or the y. And then if you are using this method, make sure that you have to place the rectangle perpendicular to the axis of revolutions. In this case, the x-axis is the axis of revolution horizontal. That's why I need to place the vertical rectangle perpendicular to the axis of revolutions. And then for the horizontal, for the y-axis of revolutions, I have to place the horizontal rectangle because I need that to be perpendicular. We need that to be perpendicular to the axis of revolutions. Now for the cell methods, instead of having pi and the radius, we are having 2 pi. The same thing, the lower to the upper limit. And then ph and then dx. Now for the cell methods, we are placing the rectangle parallel to the axis of revolution. For example, this is the y-axis. The axis of revolution is the y. That means we revolve the whole thing about the y-axis. That's why I need to place the vertical rectangle because I need that to be parallel to the axis of revolution. And then for the one that is having the x-axis at the axis of revolution or horizontal, then I need to place a horizontal rectangle because I need that to be parallel to that horizontal axis of revolutions. And p is the radius from the axis of revolution, the distance from the axis of revolution up to midway of the rectangle. And then h is just the distance, the height of the solid. Okay, the height of the rectangle. Okay, so we know that the disk and the washer, they are basically the same thing. The disk method is that when the inner radius is 0. And when the case of the inner radius r, the small r, is equal to 0, then we have the disk method. And then when the inner radius is not 0, meaning that when we have a hole, then we just call that the washer method. But washer and this, they are basically the same thing. The washer is the disk method by itself, but now there's no hole, and the disk method is just also the washer method when we have a hole or the r is 0. Now let's consider this problem. We are given a curve y equal 1 over x squared, and then this curve is bounded by y equals 0, x equal 1, and x equal 4. So 1, 2, 3, 4. This should form into a plane region. And then they ask you, find the volume when the region is revolved about 2 cases. A is when we are revolving that about the x-axis, and y is when we are revolving that around the y-axis. Okay, and see which method should I use here. So this one, the washer, or the cell method. The disk method, we place the rectangle perpendicular to the axis of revolution. The cell methods, we place the rectangle parallel to the axis of revolutions. Okay, so first thing is I must draw the region. I know that for part A, we are having 1 over x squared. This is the curve only on the right side. I mean on the quadrant 1. I don't have to draw the curve down here. it should be down here too. But because we only consider the plane region that is bounded by this curve and the y equals 0, which is what? Which is the first quadrant. And then x equal 1, x equal 4. So x equal 1 is this vertical line, x equal 4 is this vertical line, y equals 0 is just the x-axis, and then this curve. That's why we have this is the region. This is the region that is bounded by these four curves, and we are revolving that the whole thing about the x-axis. So I take the whole thing here, I revolving that around the x-axis. And now I just want to find the volume of that solid here. Okay, so I'm thinking to use the this and the Watson methods. Can I use that? The question is that if I use the this and the Watson methods, I need to place the rectangle perpendicular to the axis of revolution. In this case, the axis of revolution is the x-axis. So I need to place the vertical rectangle to be perpendicular to the x-axis. And if I place the vertical rectangle, then this is the delta x, right? This is the delta x, or everything should be in terms of dx, right? Everything should be in terms of dx. And I know that I was given the curve, this is the curve, 1 over 1, y equal 1 over x squared. I have the function in terms of x, and we are looking for the x. So we already got the function here. So we don't have to solve for anything. If you go with dy, then you have to solve for x in terms of y. And because we have x squared, let's say you want to solve for y. Okay, let's say that I want to solve for y. So y equal 1 over x squared. And then when I solve for y, I move x squared here 1 over y, and then x equal plus or minus the square root of 1 over y. Then I have to deal with the square root and a lot of stuff. And then later on I have to take the integral, and it may not be easy. Okay, we already got the function in terms of x, so why do I have to change it to y, right? If I go with delta x here, which is dx, then I got the function in terms of x. So it's easy in this case for us to use the this and the Watson methods. Now, if I use the cell methods, it would be difficult because I have to place the horizontal rectangle, and for a horizontal rectangle, I have two different limits. Between this point and this point here, this is the constant value, right? Then I have one rectangle with the height of 1, 2, 3, 4, so 3 units from here to here. Nothing is changing, but from this point here up to all the way to the top, then the height of the height in this formula, the h, is changing because we have the curve now. Then it's changing. Then I have two different limits. From 0 up to this point, the height is just 3. But from here to all the way to the top, the height is changing. So it would be difficult. So I don't want to use the cell method in this case. So this method is convenient and is just nice in this case. You don't have to solve for anything else. So using the this method, I know that the this method has for all the Watson. We have what? Pi lower to upper r squared minus the outer radius square minus the inner radius square, and then dx. So go down here. I know that we don't have any hole. The axis of revolution is the x-axis. Between this one and the solid, there's no hole. So the inner radius r, the small r of x, is 0. The outer radius is the distance from the axis of revolution, which is the x, and the curve, the outside of the curve. And this is basically just a function, the y function, or just 1 over x squared for the outer radius. And then we just apply the formula v equal pi. We go with dx, that means we are running on the x-axis, so we go from x equal 1 up to x equal 4. And then the r square, the big R square, this guy, 1 over x square, minus the small r, which is 0 square, so we don't have to minus anything, it's already 0. And then just take the integral of this one, this is 1 over x to the 4th power. And if you take the integral of that, you should end up with minus, using the power rule, is minus 1 over 3 x to the 3rd power. Now, just a quick review on how do I take the integral here. So we have 1 over x to the 4th power. We know that we can rewrite this one as x to the minus 4. So using the power rule, add 1 to that, that's become minus 3, and then over minus 3. And then if you simplify that, it's minus 1 over 3, and then bring the x to the bottom and changing the exponent to positive exponent. That's why I get minus 1 over 3 x to the 3rd power right here. Keep the pi from the outside, and we evaluate the answer from 1 to 4. So if you do that, you should get the volume to be plug in 4 to here and minus plug in 1 to here. That should give you 21 pi over 64. So in this problem, it is reasonable to use this and the Watson methods. Okay. The next problem, the next part. The next one is we are revolving the whole thing about the y-axis. Which is this problem here. The same curve. Everything is the same excepting that we are revolving that around the y-axis. Now, this is the axis of revolution here. So we are revolving that around the y-axis. So, again, we are given the same thing. So everything is in terms of x, so that I don't have to solve for. The tip here is that we are given something in terms of x already. Everything is in terms of x, so we want to keep that in all the x terms. So I want to use the dx. If I want to use the dx, make sure I have to place the vertical rectangle, because then I will have the delta x in order to use dx, right? So I have to place the vertical rectangle. And then because I place the vertical rectangle, this vertical rectangle gives me the delta x or dx, then I can use everything in terms of x. And because this is the vertical rectangle, it is parallel to the y, the axis of revolution. Because they are parallel, I should use the cell methods. Now the cell methods, I need what? Two functions, the p of x function and the h of x function. P of x is just the distance from the axis of revolution up to the middle of the rectangle, right? Which is from here up to here. And then here, if I take the rectangle right here, and then I vary it along the x-axis because we are going with dx, so I take this one, I vary that along the x-axis. Then the p of x is the distance from the axis of revolution, and then as I move along the x-axis, that distance is changing along the x-axis, or it's just the x distance. So some value of x here, as I move to the right, another value of x. As I move to the right here, another value of x. So it's just the x here, and x could be anything on the x-axis. So p of x is just x. And then the height of the rectangle, it's just the distance from x-axis to the curve. And this is just what? This is just the function of y, or 1 over x squared. So we got the p of x function, the h of x function. We can then apply the cell method. The cell method is what? The cell method is 2 pi p h and then dx. So 2 pi. We are running on the dx, which is from 1 to 4. 1 to 4. P of x is x. H of x is 1 over x squared and then dx. And this is very simple. We cancel the x and x squared, giving 1 over x dx. And the integral of 1 over x is the ln of the absolute value of x. and we evaluate the answer from 1 to 4. Keep a 2 pi constant from the outside. And then plug in 4 to here. ln of 4 is ln 4. ln of 1 is just 0. So subtract 0 is nothing. So that's why multiplying with 2 pi is give me 2 pi ln of 4. So in this case, the volume is 2 pi over 4. And this is the best way to apply the cell methods. And the tip here is that anytime that I use a dx, because I got the function in terms of x, and I place the vertical rectangle so that I can use delta x, which is dx, and I know that this rectangle is parallel to the axis of revolution. That's why they are parallel, I use the cell. Perpendicular, I use this method. Or Watson, parallel, we use the cell. And that is how you solve the problem of volume and choosing the right formula to use. And thanks for watching.